ब्याक इन्ड भयो फ्रन्ट इन्ड भयो छुट्टै भन्ने आयो होइन अनि पछि फेरि होइन यहाँ 3 जना मान्छे राख्नुभन्दा एउटा मान्छेले रिप्लेस गरे हुन्छ फुल स्ट्याक डेभलपर अर्कै फेरि अर्को नाममा होइन फेरि त्यसरी आयो अब अहिले हेर्दै जाने हो भने फेरि अब अहिले चाहिँ के छ भन्दा फेरि एकदमै जेनेरिक अब अहिले चाहिँ एकदम स्पेसिफिक भन्दा पनि 4 जनाको काम 1 जनाले गर्दिने कसले गर्छ त भनेर खोज्न थालिसकेका छन् हैन सो किन भन्दाखेरि कोड गर्न अब सजिलो रिलेटिभली पहिला भन्दा सजिलो भयो हैन सो त्यसैले गर्दा फेरि चाहिँ अब टुल्सहरु बढी एकदमै धेरै टुल्सहरु युज गर्ने तर त्यहाँबाट प्रोडक्टिभिटी कसरी जेनेरेट गर्ने त खास इन्डस्ट्रीलाई चाहिए त प्रब्लम सल्भ गर्ने त चाहियो भने हैन सो त्यसैले गर्दा फेरि हाउ वी सल्भ द प्रब्लम दैट इज द मोस्ट इम्पोर्टेन्ट थिङ है सो त्यही भएर अब अलिकति इन्टरडिसिप्लिनरी हुन थालेछ क्या जस्तो भनौं न अहिले तपाईले याद गर्नुभएको छ भने मेडिकल पर्सनहरुले एआई सिकिरहेको छ हैन अब एआई को मान्छेहरुले चाहिँ आफ्नो फिल्डमा जाँदा फेरि चाहिँ हैन अब डोमेन हेल्थ केयरमा काम गर्ने अथवा अरूमा काम गर्ने सो त्यसैले गर्दाखेरि क्रस डोमेन इज बिकमिङ मोर हैन त्यहाँ चाहिँ एउटा कोलाबोरेसन त्यो चाहिँ आइरहेको छ अब टेक्नोलोजी इकोसिस्टम नेपालको उसमा हेर्ने भनेदेखि चाहिँ हाम्रोमा यहाँ प्लेयरहरु को हुनुहुन्छ त भन्यो भने एउटा युनिभर्सिटी जसले चाहिँ हामीलाई चाहिँ युनिभर्सिटी कलेजहरुबाट हामीलाई वी गेट द नलेज ट्यालेन्ट पुलहरु त्यहाँबाट जेनेरेट हुन्छ अनि अर्को भनेको चाहिँ इन्डस्ट्री जसले चाहिँ के गर्छ भन्दा फेरि त्यो ट्यालेन्ट पुललाई कन्ज्युम गर्छ र नेपाल गभर्नमेन्ट जुन गभर्नमेन्टले चाहिँ के गर्छ भन्दा फेरि सबै ठाउँलाई चाहिँ समन्वय गर्नको लागि पोलिसीहरु उ गर्छ हैन जस्तो पोलिसी रुल्स रेगुलेशन्सहरु स्किल ट्रेनिङ होस् अथवा चाहिँ युनिभर्सिटी इन्डस्ट्रीजहरुमा टाइ अप गर्नको लागि फेसिलिटेसन गर्ने हो हैन सो यो कामहरु चाहिँ अथवा इन्फ्रास्ट्रक्चर अब डेटा सेन्टर मात्रै होइन एउटा चाहिँ प्लेटफर्म बनाइदिने पनि इन्फ्रास्ट्रक्चर हो हैन एउटा चाहिँ इन्डस्ट्री र एकाडेमिया चाहिँ एउटा डिस्कसन गर्ने प्लेटफर्म जुनमा चाहिँ गभर्नमेन्ट क्यान प्ले अ रोल्स हैन सो त्यस्तै गरेर इन्डस्ट्रीमा हेर्यो भनेदेखि चाहिँ ट्यालेन्ट पुलहरु जहाँ चाहिँ प्रोडक्ट सर्भिसेसहरु चाहिँ दिइरहेको हुन्छ त्यसको लागि चाहिँ उनीहरुले चाहिँ ट्यालेन्ट पुलहरु युज गरिरहेको हुन्छ सो अनि त्यसपछि आएर ट्यालेन्ट पुलहरु चाहिँ आखिरमा आइदर इन्डस्ट्री अथवा एकाडेमिया हैन अब हुन त एजुकेसन सेक्टरलाई पनि एउटा चाहिँ इन्डस्ट्री अथवा इन्डस्ट्री भनेर त्यसरी एकाडेमिया मानिन्छ तैपनि एउटा चाहिँ टेक सेक्टरको के सरी एजुकेसन सेक्टरको हेर्ने भने त्यहाँ पनि कन्ज्युम हुने हिसाबले चाहिँ इन्डस्ट्रीमा चाहिँ यो ट्यालेन्ट पुलहरु चाहिँ कन्ज्युम हुन्छ र युनिभर्सिटिजहरुको रोल भनेको चाहिँ हाइली ट्यालेन्टेड पुलहरु हैन प्रोड्युस गर्ने रोल रहन्छ अब यति भन्दै गर्दा फेरि हामीसँग यो स्टेक होल्डरमा कुनै पनि एउटा स्टेक होल्डरले राम्रोसँग काम गर्दिएन भने सोच्नुस् त गभर्नमेन्टले राम्रोसँग रुल बनाइदैन अथवा गभर्नमेन्टले लेट सपोज एउटा कलेजबाट चाहिँ अथवा एउटा युनिभर्सिटीबाट चाहिँ एटलिस्ट 10 वटा चाहिँ ए र्याङ्किङ पेपरमा चाहिँ अथवा कन्फरेन्समा जर्नलमा पेपर पब्लिश हुनुपर्छ भनेर रुल बनाइदिनु भने के हुन्छ त सो एभ्रीबडी फर्स्ट टु डु दैट हैन सो त्यसैले गर्दा फेरि गभर्नमेन्टको रोललाई बिर्सिन हुँदैन हामीले हैन गभर्नमेन्ट जति स्ट्रङ त्यसले चाहिँ एउटा चाहिँ रुल बनाएर बाइन्डिङ गरिदिने हैन र प्लेटफर्म बनाइदिने हैन सो अब पक्कै पनि हाम्रो रियल ग्राउन्ड के हो त्यसलाई कसरी गर्न सकिन्छ त्यो पनि गभर्नमेन्टकै उसमा आउँछ सो हेर्नुस् त इन्डस्ट्री यदि युनिभर्सिटिजले राम्रोसँग नपढाइदिने हो र डिग्री मात्रै दिने हो हैन प्रब्लम सल्भर चाहिँ बनाउने होइन तर सर्टिफिकेट चाहिँ दिने हो भयो भने के हुन्छ त त्यो मेन पावर गएर इन्डस्ट्रीमा हैन इन्डस्ट्रीले राम्रोसँग चाहिँ नि काम गर्न सकेन भने के हुन्छ फेरि हैन सो त्यसैले गर्दा फेरि यो सबै चीजहरु एकअर्कासँग एकदम इन्टरलिङ्क छ र यो चीजको आधारमा चाहिँ हामीले चाहिँ त्यो ग्यापहरुलाई कसरी रिड्युस गर्न सकिन्छ भन्ने छ सो त्यसैले गर्दा फेरि यहाँनेर हेर्नु भयो भने जस्तो 30 खर्ब चाहिँ हैन सो 5 लाख डाइरेक्ट जब दिने भनेर गभर्नमेन्टले भनेको छ हैन सो आईटी मा हेर्यो भने आईटी टिकट बनाउँदा फेरि अब सोध्नुस् त वर्षको 10,000 प्रोड्युस भइराछ 5 लाख जना कहिले पुग्छ होला त राइट अब एक्जिस्टिङ कति छ हैन हामी त खासै 5 लाख त छैनौं हैन सो त्यसैले गर्दा फेरि हामीले भिजन बनाउँदा फेरि चाहिँ अब युनिभर्सिटी ट्यालेन्ट पुल हाम्रो त्यसको उहरु हैन सो त्यसलाई चाहिँ गभर्नमेन्टले फेसिलिटेट गर्नुपर्छ कसरी सम्भव छ त यो हैन के गर्नुपर्छ त कहाँनेर इन्टरभेन्सन गर्नुपर्छ त भन्ने चीज अनि डिजिटल फ्रेमवर्कले पनि हेर्दा फेरि चाहिँ विभिन्न सेक्टरहरु आइडेन्टिफाई गरेर हैन तपाईले चाहिँ एज अ स्टुडेन्ट यु शुड लर्न दैट भन्छ के म चाहिँ हैन जो ग्रेजुएट हुँदै हुनुहुन्छ अथवा ब्याचलर लेभलको हुनुहुन्छ यो तपाईहरुले पनि एटलिस्ट नेपालको आईटी सेक्टरमा कसरी प्रायोरिटी गभर्नमेन्टले के गरिरहेछ कम्प्लायन्स के छ हैन और यसले चाहिँ तपाईलाई एक्स्ट्रा बनाइदिन्छ कि अब कोड गर्न आउने आईटीमा हुनुहुन्छ ल कोड गर्न आउँछ भन्यो भने अब व्हाट इज द एक्स्ट्रा त्यो त अब कति चीजहरु चाहिँ यो अहिले चाहिँ च्याट जीपीटीहरु जस्तो टुलहरुले पनि फेसिलिटेट गरिदिरा हुन्छ के सो व्हाट इज द डिस्टिंग्विशिङ फ्याक्टर त है सो त्यसैले गर्दा फेरि अलिकति स्टे ट्युन हाम्रो वरिपरि के भइरहेछ संसार कतातिर जाँदैछ अबको 5 वर्षपछि म यही सिकेर चाहिँ यसले नै म सर्भाइभ हुन सक्छु त हैन सो दैट काइन्ड अफ माइन्डसेट ग्रोइङ माइन्डसेट भनौँ है सो यु शुड ह्याभ दैट माइन्डसेट है अनि नेशनल पोलिसी 2082 एआई को अहिले भर्खरको हैन सो सोभरियन एआई भनेको छ हैन सो अनि एआई लाई अलिकति फोकस गरेर हाम्रो डेटा ओनरशिप प्राइभेसी हैन ट्रान्सपेरेन्सी अहिले कति प्रब्लमहरु छ हैन जस्तो चाहिँ मिस इन्फर्मेसन डिसइन्फर्मेसन हेर्नु त अहिले हैन फेक भिडियोजहरु हैन सो वी हेभ अ लट्स अफ प्रब्लम तर हामीले त्यो प्रब्लम सल्भ गर्नतिर सोचिरहेको छौं त एज हामी पढ्दै गर्दा फेरि हैन हामीले चाहिँ गभर्नमेन्टले यो गरेन अथवा कलेजले करिकुलममा राखेन सिलेबसमा भन्दै गर्दा फेरि चाहिँ आर वी रेडी टु टेक दैट रेस्पोन्सिबिलिटी है त्यो चाहिँ एकदम इम्पोर्टेन्ट लाग्छ अनि जस्तो फर एक्जाम्पल अर्को एउटा चाहिँ के छ भन्दा फेरि जस्तो हामी जब फ्रेश ग्रेजुएट हैन यो इन्डस्ट्रीमा जाँदा फेरि एउटा फ्रिक्सन जहिले पनि रहन्छ के जस्तो चाहिँ हैन अब फ्रेशर लिन त लिने हो तर त्यो हामीले खोजे जस्तै भेटिएन भन्ने चाहिँ छ के तर के हुन्छ भन्दा फेरि हामीसँग ट्यालेन्ट नभएको छ हैन 4 वर्ष पढ्दाखेरि पढेका चाहिँ हुन्छौं हैन तर त्यो सानो सानो ग्लिचेसहरु के हैन अब इफ यु हेभ अ फाउन्डेसन स्ट्रङ डाइनामिक माइन्डसेट भन्यो भनेदेखि चाहिँ मलाई एउटा एक्जाम्पल एकदम मन पर्छ क्या जस्तो ग्रेजुएट युनिभर्सिटीको रोल भनेको कुनै पनि एउटा इन्डस्ट्रीको लागि चाहिँ सफ्टवेयर डेभलपर अथवा पर्टिकुलर पोजिसनको लागि स्टुडेन्ट तयार गर्ने होइन हैन किनभने युनिभर्सिटीको रोल भनेको बिगर अन दैट हामी यहीबाट रिसर्चर होलाउ पोलिसी बनाउने मान्छे होलाउ अथवा एन्टरप्रेन्योर होलाउ यहीबाट चाहिँ हामी सबै चीजलाई पुग्ने गरेर बनाएर आउँछौं हैन सो त्यसैले गर्दा फेरि युनिभर्सिटीको रोल भनेको एउटा लाग्ने तरबार बनाएर पठाउने हो के अनि उले कहाँ युज गर्छ कहाँ जहाँ जान्छ त्यहाँ चाहिँ उ डाइनामिकली एडप्ट हुने हो अब त्यो माइन्डसेट बनाएर पठाउने एउटा चाहिँ स्किल छ अर्को माइन्डसेट के एउटा स्किल जान्नु पर्ने र अर्को माइन्डसेट चाहिँ म चाहिँ एडप्ट हुनुपर्छ नयाँ सिचुएसनमा पनि आई क्यान ह्यान्डल दिस भन्ने जुन एउटा माइन्डसेट बनाएर पठाउनु पर्छ नि हैन सो युनिभर्सिटीको रोल त्यहाँबाट हुन्छ हैन सो युनिभर्सिटीले त्यसरी सोचिरा हुन्छ अब अहिले कहिले इन्डस्ट्रीले चाहिँ के हुन्छ भन्दाखेरि आएर भोलिपल्टै आउटपुट दिँदै हुन्थ्यो भन्ने कम्पनीदेखि लिएर हैन आएपछि हामी 2-3 महिना चाहिँ ट्रेन दिएर ट्रेनिङ गराएर अनि बल्ल हाम्रो चाहिँ बल्ल इन्ट्री गराउँछौं भन्ने पनि मेन पावरहरु चाहिँ हुनुहुन्छ हैन सो इन्डस्ट्रीहरु हुन्छ त्यहाँ पनि धेरै भेराइटीहरु देखिन्छ सो त्यसैले गर्दा फेरि हामीले चाहिँ पढ्दै गर्दाखेरि के बुझ्नु पर्यो भन्दा फेरि एआई के हो अनि त्यसपछि आएर यो ट्रेन गर्यो अनि त्यसपछि मोडल जेनेरेट गर्यो सक्यो भन्नु भन्दा पनि यसलाई डिप्लोय गरेर कस्ट कति लाग्छ हैन अलिकति गो विथ एक्स्ट्रा माइल्स के प्रोजेक्ट गर्यो अलिकति गर्यो सक्यो हैन त्यो प्रोजेक्टलाई डिप्लोय गरे कति कस्ट लाग्दो रहेछ त कसरी अप्टिमाइज गर्न सकिन्छ यदि यो चाहिँ 100 जनाले अथवा 1 लाख जनाले एकैचोटी चलाउँदा फेरि कति लाग्छ त सो यो माइन्डसेट अलिकति यो चाहिँ मैले एउटा एक्जाम्पल भने हैन सो त्यसैले गर्दा फेरि यो चाहिँ अब इन्डस्ट्रीमा चाहिँ त्यो चीज चाहिने वाला छ के सो त्यसैले गर्दा त्यो त अब सिलेबसमा हुँदैन त्यो चाहिँ के हुन्छ हामी प्रोजेक्ट गर्दा होस् अथवा चाहिँ हामी पढ्दाखेरि होस् अनि त्यो क्युरियोसिटी र यो एक्टिभ लर्निङ एक्सपेरिमेन्ट गर्ने पढ्ने फेरि एक्सपेरिमेन्ट गर्ने फेरि हेर्ने सो एक्टिभ लर्निङ हैन प्यासिभ लर्निङ होइन एक्टिभ लर्निङ जब हामीले स्टार्ट गर्छौं देन हाम्रो माइन्डसेट अनि त्यसपछि ठुलो हुँदै जान्छ अनि ए ल अन व्हाट नेक्स्ट हैन सो त्यो एउटा माइन्डसेट छ अनि सँगै अर्को मैले भने रेगुलेसन कम्प्लायन्सहरु हैन हामी इन्डस्ट्रीमा गइसकेपछि चाहिँ यो कुराहरु तर अब रेगुलेसन कम्प्लायन्स सिलेबसमा छैन रे अब के गर्ने त कलेजलाई त अब बसुन्जेल त कलेजलाई पनि भन्न पाइन्छ युनिभर्सिटीलाई पनि भन्न पाइन्छ तर इन्डस्ट्री गइसकेपछि चाहिँ त्यो पाइदैन फेरि हैन सो त्यसैले गर्दा फेरि यो चीजहरु अलिकति यो चाहिँ ओपन माइन्ड भएर यस्तो रेगुलेसन कम्प्लायन्सहरु हैन सो मैले चाहिँ गभर्नमेन्टलाई अब फोकस गर्दिन सो डाइरेक्टली आई कम टु द एकाडेमिया एन्ड इन्डस्ट्री। सो अलिकति त्यसलाई अलिकति न्यारो डाउन गरेर हेरौँ भनेर है, अहिले भनेको बिगर पिक्चरमा लेट्स ओन्ली फोकस अन इन्डस्ट्री र एकाडेमियामा चाहिँ कहाँनिर चाहिँ अझै अलिकति उ गर्न सकिन्छ भनेर हैन। सो थ्योरी एन्ड फन्डामेन्टल इन्जिनियरिङ प्रिन्सिपल्सहरू अब यो चाहिँदैन भन्यो भने पक्का चाहिन्छ, किन भन्दा फेरि ग्राउन्डेडै राम्रो छैन भनेदेखि छत हाल्न सकिँदैन है। सो यु शुड ह्याभ अ सलिड फाउन्डेसन फर द्याट है। सो युनिभर्सिटिज मस्ट मुभ फरवर्ड द रिसर्च ओरिएन्टेड एक्टिभिटिज टु सल्भ द रियल वर्ल्ड प्रब्लम है। अब हाम्रो चाहिँ कहाँनिर चाहिँ मिसिङ हुन्छ एउटा चिज भन्दाखेरि वी क्यान ह्याभ अ सलिड फाउन्डेसन थ्योरी ब्याकग्राउन्ड, तर रियल प्रब्लमसँग कनेक्ट गर्ने क्या, त्यसलाई कहाँनिर कनेक्ट गर्न मिल्छ त्यो मिसिङ लिङ्क जुन अब हामी के नेपालमै हेऱ्यो भनेदेखि अथवा संसारमै हेऱ्यो भनेदेखि चाहिँ प्रब्लम चाहिँ हाम्रो हजुरबुवाहरूको पालामा पनि थियो, बुवाहरूको पालामा पनि थियो, हाम्रो पालामा पनि छ, हाम्रो छोराछोरीहरूको पालामा पनि हुन्छ, नाति नातिनाको पालामा पनि हुन्छ। सो के कुरा सिक्यो भने चाहिँ अथवा के कुरा चाहिँ पहिला पनि युज थियो, अहिले पनि युज हुन्छ, पछि पनि युज हुन्छ त फन्डामेन्टल थिङ्सहरू हैन। एउटा चाहिँ त्यो टेक्नोलोजी रिलेटेड छ, अर्को चाहिँ माइन्डसेट जुन चिज प्रब्लम सल्भिङ स्किल्स हैन। तपाईँले हेर्नु भने एउटा प्रब्लम स्किल एकदमै राम्रो चाहिँ सल्भ गर्ने स्किल भएको मान्छेले जुनसुकै डोमेनमा हात हाले पनि उसले प्रब्लम सल्भ गर्ने स्किल उसँग हुन्छ। सो त्यो चिज त कहाँ पढाइ हुन्छ त फेरि भन्यो भने सिलेबसमा ठ्याक्कै चाहिँ कोर्स करिकुलममा त हुँदैन है। सो त्यसैले गर्दाखेरि हामीले चाहिँ प्रब्लम स्किल अहिले म आउँछु त्यसमा हैन, हामीसँग एउटा चाहिँ टेक्निकल स्किल सफ्ट स्किल्स हैन। सो त्यही भएर चाहिँ जस्तो अरू पनि धेरै चिजहरू जुन चाहिँ के हुन्छ भन्दाखेरि तपाईँले पढ्नु भएको 40-50 वटा सब्जेक्टहरू पढ्नुहुन्छ, सबै चिजमा एउटा कमन चिज के हुन्छ त भनेर खोज्यो भने ह्याबिट्स लाइक द्याट हैन। सो त्यसैले गर्दाखेरि त्यो एउटा चाहिँ कमनालिटिज हैन, प्रब्लम सल्भिङ स्किल होस्, त्यस्तै अरू पनि धेरैवटा चिजहरू होस्, कम्युनिकेसनहरू तपाईँले पढेको चिज भन्न सक्नुहुन्छ कि सक्नुहुन्न हैन। तपाईँ टेक्निकल मान्छे हो भने नन टेक्निकल मान्छेलाई 2 मिनटमा तपाईँले जानेको कुरा बुझाउन सक्नुहुन्छ कि सक्नु हुँदैन। सो द्याट इज अल्सो स्किल हैन। कति ठाउँमा त इलिभेटर पिच भन्छ हैन, इलिभेटरमा चाहिँ माथिबाट तल जाँदाखेरि पिच गरेर चाहिँ आफ्नो आइडिया सेल गर्न सक्छ कि सक्दैन हैन, द्याट टाइप अफ स्किल्स हैन। सो त्यसैले गर्दाखेरि लट्स अफ थिङ्स छ। सो त्यसैले गर्दा अब इन्डस्ट्रीमा चाहिँ त्यही भएर युनिभर्सिटीमा चाहिँ हामीले रियल वर्ल्ड प्रब्लम सल्भ गर्ने रिसर्च ओरिएन्टेड हैन, अनि त्यसपछि आएर त्यो एउटा प्लेटफर्म बनाउने, हामीले फ्याकल्टीहरूलाई रिटेन गर्ने हैन, त्यो त्यस्तो फ्याकल्टीहरू चाहिँ एट्र्याक्सन गर्ने, त्यस्तो चिजहरूलाई उ गर्ने। सो युनिभर्सिटीको साइडबाट गर्नुपर्ने त्यो पार्ट हुन्छ भने इन्डस्ट्रीको साइडबाट चाहिँ कम्पनीले चाहिँ प्रडक्ट बनाएर आउटपुट दिने नै खोजिरहेको हुन्छ हैन। त्यो सो त्यसैले गर्दाखेरि हामीले चाहिँ र अनि कम्पनीमा काम गर्दाखेरि इन्डस्ट्रीमा काम गर्दाखेरि चाहिँ इन्डिभिजुअल एकजना चाहिँ वान म्यान आर्मी हुँदैन। वान म्यान आर्मी भएपछि वान म्यान आर्मी भयो भने स्टार्टअप प्रोजेक्टसम्म हुन्छ, तर कम्पनी रन हुँदैन। कम्पनीमा चाहिँ कोलाबोरेटिभ वर्क चाहिन्छ। अब कोलाबोरेटिभ वर्क चाहिनको लागि चाहिँ अब तपाईँ चाहिँ कसरी काम गर्न सक्नुहुन्छ, कसरी कोलाबोरेट गर्न सक्नुहुन्छ, रेस्पेक्ट कसरी गर्नुहुन्छ अर्कालाई, आफ्नो कुरा कसरी भन्न सक्नुहुन्छ। सो लट्स अफ थिङ्स हैन विच आर द बियोन्ड द सिलेबस। तर हामीले चाहिँ यहीँ चाहिँ प्रोजेक्ट गर्दाखेरि सिलेबस गर्दाखेरि पढ्दाखेरि चाहिँ वी क्यान प्र्याक्टिस द्याट है। सो सो इन्डस्ट्रीले चाहिँ त्यही भएर चाहिँ के हुन्छ डिप्लोइमेन्ट रेडी ट्यालेन्टहरू हैन, एउटा चाहिँ उसलाई भनेको काम दिएको काम उसले कसरी गर्ने हो उसले गरोस् हैन। सो द्याट काइन्ड अफ सोल्युसन ओरिएन्टेड चाहिँ गरिरहेको हुन्छ हैन। सो मैले चाहिँ मलाई आफूलाई लागेको चाहिँ एकाडेमिया र इन्डस्ट्रीमा हामीले हेर्दाखेरि दुईटा साइडबाट हेरेको छु क्या मैले चाहिँ। एउटा भनेको चाहिँ एडभान्स स्किल भयो जुन भनेको चाहिँ हामीले जुन हामी सिलेबसहरूमा पढिरहेको हुन्छौँ, स्टेट अफ द आर्ट टुल्सहरू, टेक्नोलोजिज हैन, टुल्स एन्ड टेक्निक्सहरू, अनि प्र्याक्टिकल ह्यान्ड्स अन स्किल्सहरू हैन, अनि रिसर्चहरू गरिरहेको हुन्छौँ, प्रब्लम सल्भिङ स्किल्सहरू पढिरहेको हुन्छौँ। अझ यसलाई सफ्ट स्किलमा राख्दा पनि हुन्छ है, तर मैले चाहिँ माथि यो चाहिँ प्रब्लम सल्भिङ भन्ने चाहिँ अलिकति। अनि सफ्ट स्किलमा चाहिँ कम्युनिकेसन क्या, जस्तो आई अल्सो फिल द्याट वेन आई गो अब्रोड होइन अनि काम गर्न चाहिँ आउने तर लेख्न नआउने क्या आई फिल द्याट होइन कतिजनाले चाहिँ काम ठिकै ठिकै गरेछ लेख्दाखेरि त होइन चाहिँ त्यो लेख्ने पनि एउटा कम्युनिकेसन होइन प्रेजेन्टेसन गरे हो नि त होइन स्लाइड बनाउने होइन सो क्यान यु मेक अ गुड स्लाइड्स होइन स्लाइड कतिको राम्रो बनाउन हाउ मच टाइम यु स्पेन्ड टु मेक अ स्लाइड्स स्लाइड बनाउँदा फेरि अडियन्स फोकस गरेर हामीले स्लाइडहरू कतिको बनाउँछौँ होइन सो त्यो कम्युनिकेसन स्किल्सहरू प्रेजेन्टेसन स्किल्सहरू होइन लिडरसिप इन्टरप्रेन्योरसिपहरू होइन प्रोफेसनल इथिक्स एन्ड बिहेभियरहरू होइन जस्तो अब कति कन्ट्रीहरू चाहिँ इथिक्स बिहेभियरमा एकदम राम्रो सुनिन्छ होइन अब हामीले खास गऱ्यो भने कस्तो हुन्छ भन्दाखेरि इभन बाहिरबाट आउटसोर्सिङ कामहरू आयो भने सुरुमा चाहिँ को मान्छेलाई दिएको होइन कुन देशमा आयो भन्ने हुन्छ क्या अनि त्यो देशको रिप्रेजेन्टेसन को हो त भने हामी इन्डिभिजुअल हौँ होइन सो त्यसैले गर्दाखेरि इथिक्स बिहेभियरहरू अनि रेजिलियन्ट होइन आउटपुट आएन कतिसम्म आउटपुट नआउँदासम्म चाहिँ काम गर्छौँ त हामी त्यो रेजिलियन्ट पावर होइन फेल हुँदा पनि फेरि चाहिँ उठ्न सक्ने पावर जुन रेजिलियन्ट होइन सो त्यो चिजहरू हेर्दाखेरि यसलाई आउँछ अलिकति फर्दर जाने भनेदेखि चाहिँ फर्स्टमा चाहिँ के गर्नु पर्यो भन्दाखेरि त्यो ग्यापलाई होइन वाट एभर सिलेबस वी हेभ वाट एभर द कोर्सेस वी हेभ होइन फाउन्डेसन त हाम्रो राम्रो छ नेपालको फाउन्डेसन एकदम राम्रो छ होइन आई प्राउडली से द्याट है हाम्रो चाहिँ फाउन्डेसन जुन थ्योरी होइन फाउन्डेसनहरू एकदमै राम्रो छ होइन सो तर अब हामीले के गर्नु पर्यो भन्दाखेरि एज अ स्टुडेन्ट होइन हामी ग्रेजुएट हुँदैछौँ गर्दैछौँ भने पनि जस्तो हामीले चाहिँ ट्र्याक इन्डस्ट्री ट्रेनहरू होइन जस्तो एआईको सेक्टरमा होइन हाइड्रोको सेक्टरमा इलेक्ट्रिकल इलेक्ट्रोनिक्सको सेक्टरमा सो हाउ द वर्ल्ड इज मुभिङ होइन त्यो एउटा अनि अर्को चाहिँ त्यससँगै चाहिँ हाम्रो चाहिँ स्टेट अफ द आर्ट टेक्नोलोजिजहरू कतिजनाले भनिरहेको हुन्छ क्या जस्तो इन्डस्ट्रीमा जाँदाखेरि कोडिङ गर्न आउँछ भने आउँछ भने गिटअप चलाउन आउँछ भने आउँदैन भन्छ क्या अब गिटअप चलाउने सिलेबस त हुँदैन होइन सो त्यसैले गर्दाखेरि हामीले चाहिँ त्यो इन्डस्ट्री होइन गिटअप कोडहरू पुश गर्ने स्टेट अफ द आर्ट होइन कुराहरू चाहिँ सिक्दै जानुपर्ने होइन सो अनि अब नयाँ टेक्नोलोजी होइन डकर क्युबरनेटिक्सहरू अब एआईतिर जाने भने त्यस्तै गरेर इलेक्ट्रिकलको आफ्नै होला इलेक्ट्रोनिक्सको आफ्नै होला सरी मलाई त्यो सेक्टरतिर चाहिँ त्यति थाहा छैन तर हामीले चाहिँ आफ्नो त्यो चिजहरू चाहिँ यु सुड स्टे ट्युन विथ द टुल्स एन्ड टेक्नोलोजिज वाट इज द करेन्ट टुल्स एन्ड टेक्नोलोजिज होइन अनि रियल वर्ल्ड डेटाहरूसँग खेल्ने रियल वर्ल्ड प्रब्लमसँग खेल्ने गर्नुपर्छ क्या जस्तो हामीले चाहिँ पाउने डेटा चाहिँ सजिलो छ क्लिन छ होइन कागलहरूबाट डाउनलोड गर्छौँ कहिले कहिले एकदमै क्लिन हुन्छ क्या अनि इन्डस्ट्रीमा गएर त्यही प्रब्लम गर्न लायो भने अब गर्न आउँछ मलाई फाइनेन्सियल डेटाको यो एनामली डिटेक्सन गर्न आउँछ भनेको छ गएर डेटा देखाइदिइसकेपछि चाहिँ अनि यस्तो चाहिँ नि मिसिङ डेटा यस्तो चाहिँ नि नराम्रो डेटा त मलाई थाहा छैन भन्ने क्या होइन सो त्यसैले गर्दाखेरि रियल वर्ल्डको रेप्लिका चाहिँ हामीले बनाएर सिक्नुपर्छ वाट एभर यो एउटा चाहिँ जस्ट इक्जाम्पल भयो तर हामीले के गर्दा नि रियल वर्ल्डको हामीले प्रोजेक्ट गर्दा अथवा वाट एभर असाइनमेन्टहरू गर्दाखेरि चाहिँ अथवा हाम्रो एकाडेमिक सेटिङमा चाहिँ हाउ नाइसली वी क्यान रेप्लिकेट द्याट द रियल वर्ल्ड प्रब्लम विथ आवर एकाडेमिक सेटिङ्स होइन त्यसमा टिचरले हेल्प गर्नु होला होइन अथवा हाम्रो सिलेबसले अथवा चाहिँ एक्सपर्टसँग कोअर्डिनेसन हामीले चाहिँ कुनै डोमेनमा काम गर्न खोजिरहेछौँ भने त्यो डोमेन एक्सपर्टसँग कति गफ गर्छौँ होइन सो द्याट काइन्ड अफ सेटिङ जुन चाहिँ रियल वर्ल्डमा जे हुन्छ त्यसलाई चाहिँ हाम्रो चाहिँ एकाडेमिक सेटिङमा कसरी लिएर आउने त सो यसमा चाहिँ टिचरको पनि रेस्पोन्सिबिलिटी छ र मोस्ट इम्पोर्टेन्ट चाहिँ स्टुडेन्टको इन्ट्रेस्ट होइन स्टुडेन्टको इन्ट्रेस्ट चाहिँ एकदमै इम्पोर्टेन्ट हुन्छ र अब हामीले चाहिँ अर्को चाहिँ अब कल्चरल एस्पेक्ट पनि हो होइन सो हामीले चाहिँ एकाडेमिया इन्डस्ट्रीको चाहिँ सँगै काम गर्ने प्र्याक्टिसहरू होइन कति चाहिँ नेपालमा हामी प्र्याक्टिस गरिरहेको छौँ त्यसले पनि डिटरमाइन गर्छ तर पनि एटलिस्ट हामीले चाहिँ एउटा के बुझ्नु पऱ्यो भन्दाखेरि हामी रियल वर्ल्डमा गइसकेपछि गर्ने काम एकाडेमिक सेटिङमा चाहिँ अहिले सिक्न सक्छौँ सक्दैनौँ त होइन यदि सिलेबसले कभर गर्दैन भने आर वी विलिङ टु लर्न द्याट है त्यो एउटा चाहिँ इम्पोर्टेन्ट लाग्छ अनि अर्को चाहिँ स्किल्सहरू है डिप्लोयमेन्ट स्किल्सहरू भयो। अनि अर्को चाहिँ इन्टर्नसिपहरू है। अब इन्टर्नसिप चाहिँ के छ भन्दाखेरि आई डोन्ट नो धेरै ठाउँमा चाहिँ मेबी कति ठाउँमा चाहिँ 4th इयर गइसकेपछि इन्टर्नसिप सुरु गर्ने, कसैले सकाइसकेपछि इन्टर्नसिप सुरु गर्ने, कसैले चाहिँ 2nd इयर सकाइसकेपछि इन्टर्नसिप सुरु गर्ने होइन। सो यो चाहिँ डिफ्रेन्ट फ्याक्टर्सहरूले डिटरमाइन गर्छ। सो हाम्रो क्लासको टाइम अरू कुराहरू होइन। तर मेन इम्पोर्टेन्ट कुरा चाहिँ के हुन्छ, इन्टर्नसिपमा चाहिँ प्रायः जसो चाहिँ अब्जर्भेसन, त्यो एकदमै इन्गेजिङ भन्दा पनि अब्जर्भेसन र अलिकति थोरै त्यो रियल वर्ल्ड भन्दा चाहिँ अलिकति सिमुलेटेड इन्भाइरोमेन्टमा अथवा अरू चिजमा चाहिँ गर्ने हुन्छ। तर हामीले चाहिँ एउटा के हुन्छ चाहिँ इन्टर्नसिप गर्न जाँदाखेरि चाहिँ मलाई कति पैसा दिन्छ भनेर चाहिँ माइन्डसेट छ भनेदेखि यु आर नट गोइङ फर लर्निङ के। तर मैले त्यहाँ के सिक्छु भन्ने मनसायले चाहिँ इन्टर्नसिप चुज गर्नुभयो भने, सो त्यसैले गर्दाखेरि त्यो अब्जर्भेसन रोल मात्रै छ भनेदेखि जस्ट अभोइड द्याट होइन। मलाई गदाको जसरी पेलाए पनि हुन्छ तर मैले सिक्छु होइन, त्यो माइन्ड सेटले गयो भनेदेखि चाहिँ अनि बल्ल चाहिँ त्यस्तो खाले इन्टर्नसिप चाहिँ चुज गर्नुहोस् भन्छु म चाहिँ है, मेरो रिकमेन्डेसन चाहिँ। अनि अर्को भनेको चाहिँ मेबी जस्ट सजेसन 80-20 होइन। जस्तो फाउन्डेसन हाम्रो सिलेबस यताउता कुराहरू जुन फाउन्डेसन स्ट्रङ बनाउनलाई 80%, तर एटलिस्ट 20% एटलिस्ट है, यो एटलिस्ट 20% चाहिँ लर्न द करेन्ट टुल्स एन्ड टेक्नोलोजिजहरू, करेन्ट ट्रेन्डहरू होइन, ऊहरू अबको 5 वर्षमा के आउँछ त होइन। सो त्यस्तो चिजहरू पढ्ने, अब त्यो सिलेबसमा त कभर हुँदैन। सो त्यो चिजहरू चाहिँ हामीले अहिले नै होइन, हामीले चाहिँ अब अहिले त इन्फर्मेसन अमेरिकामा पढ्नु, अस्ट्रेलियामा पढ्नु, नेपालमा पढ्नु केही पनि फरक छैन, हामीसँग इन्फर्मेसन त उही नै छ होइन। सो त्यसैले गर्दाखेरि हामीले चाहिँ 20% चाहिँ इमर्जिङ टेक्नोलोजिसहरूमा है, सो त्यसमा चाहिँ अलिकति हामीले टाइम दिन सक्यो भनेदेखि चाहिँ अनि राम्रै हुन्छ। अब अरू चिजहरू चाहिँ ओपन सोर्स प्रोजेक्टहरूमा कन्ट्रिब्युट गर्नुहोस्, त्यो गर्दाखेरि तपाईँको इन्टरनेसनल फ्रेन्ड्सहरू हुन्छन्, तपाईँसँग कोलाबोरेसन गर्ने हुन्छ, तपाईँसँग कम्युनिकेट गर्ने स्किल्सहरू बढ्छ होइन। सो त्यसैले गर्दाखेरि यस्तो चिजहरू ह्याकाथोन्स कम्पिटिसनहरू होइन, अनि सो यु क्यान पार्टिसिपेट द्याट होइन, ह्याकाथोनहरू त्यसले चाहिँ रियल वर्ल्ड प्रब्लमहरूमा होइन सल्भ गर्ने ट्राई गर्नुहोस्। सो त्यसले चाहिँ के गर्छ भन्दाखेरि एउटा टिम वर्क, टिम बिल्डिङ होइन, र आफूले सोचे मात्रै हुँदैन, मान्छेले अर्को तरिकाले पनि सोच्दो रहेछ, अर्को डोमेनको मान्छेले पनि कसरी सोच्दो रहेछ। सो दिस काइन्ड अफ थिङ्स यु लर्न द्याट। अनि त्यस्तै गरेर अलिकति रिसर्चहरू गर्ने, ब्लगहरू पोस्ट गर्ने होइन, लेख्ने बानी, जसले कम्युनिकेसन स्किल्सहरू गर्छ अहिलेको जुन त्यो सफ्ट स्किल्सहरूको कामहरूमा चाहिँ होइन। सो सफ्ट स्किलमा चाहिँ तपाईँहरूले प्रेजेन्टेसन दिँदाखेरि चाहिँ हाउ नाइसली, हाउ मच टाइम यु गिभ टु मेक स्लाइडहरू बनाउँदाखेरि होइन, दिस इज भेरी इम्पोर्टेन्ट। यु लर्न सो मेनी थिङ्स। स्लाइड चाहिँ तपाईँले एकदमै टाइम लगाएर बनाउनु भयो भने आई क्यान ग्यारेन्टी द्याट इट्स वर्दी, इट्स भेरी भेरी वर्दी। तपाईँले एउटा स्लाइड बनाउँदा पनि एकदमै टाइम मेहनत लागेर छ, अडियन्स को छ, मैले कसरी बुझाउन सक्छु। यु लर्न सो मेनी थिङ्स, यु आर नट जस्ट मेकिङ द स्लाइड्स क्या, यु लर्न सो मेनी थिङ्स होइन। रिफ्लेक्ट गर्ने स्लाइड बनाउँदाखेरि ल फिडब्याक आयो इन्कर्पोरेट गर्ने होइन। सो त्यो कुराहरू प्रब्लम सल्भिङ स्किल्स होइन। यो प्रब्लम सल्भिङ स्किल्स त होइन थाहा पाएदेखि अहिलेसम्म र पछिसम्म पनि अब काम लाग्ने स्किल्स हो। सो हाउ यु ट्याकल विथ द प्रब्लमहरू होइन, हेर्नुभयो भने त्यहाँ एउटा प्याटर्न देख्नुहुन्छ तपाईँले होइन। तपाईँले आफूले अहिलेसम्म कतिवटा प्रब्लम सल्भ गर्नुभयो, त्यो कसरी सल्भ गर्नुभयो भनेर वेन इफ यु आर रिफ्लेक्ट द्याट थिङ्स यु सी द प्याटर्न देयर यु नो। मेरो आफ्नो एउटा चाहिँ मैले आफूलाई फिल लागेको प्याटर्न होइन चाहिँ हाउ बिग द प्रब्लम इज, द स्किल लाइज इन हाउ नाइसली यु क्यान डिकम्पोज द्याट बिगर प्रब्लम इन्टु द स्मलर प्रब्लम, and then how you solve the smaller problem and then how you integrate that things हैन। सो तपाईहरुले आफ्नो एउटा लर्निङ, आफ्नो एउटा प्याटर्नहरु हुन्छ। सो think about the top 10 problem you solved till now, then see the pattern है। सो त्यो भएपछि अनि that can applies to the anywhere है। सो leadership, entrepreneurship, take the ownership हैन। leadership भनेको चाहिँ एक हामी कति ओनरशिप लिन्छौं त्यो कामको, हाउ बिग ओनरशिप यु टेक यु विल बी मोर लिडर है मलाई लाग्छ एउटा हैन लिडिङ गर्ने अर्कालाई काम लाउने लिडर मात्रै लिडरशिप होइन लिडरशिप भनेको चाहिँ रेस्पोन्सिबिलिटी कति लिइन्छ सो आफ्नो प्रोजेक्ट काम गर्दाखेरि हामी चाहिँ फ्री राइडर हुन जान्ने मान्छे खोजेर टिममा खोजेर हिँडिरहन्छौँ कि त्यसको रेस्पोन्सिबिलिटी लिन्छौँ सो यो सानो चिजले यही बिउ हो हामीलाई पछि हैन यो चाहिँ बिउ हो क्या हैन यही बिउ चाहिँ झाँगिँदै जाने हो जहिले पनि हामी चाहिँ सेफ हैन अनि अलिकति रिस्क लिन छोड्ने त्यस्तो बढ्दै जान्छ अनि प्रोफेसनल इथिक्स बिहेभियरहरू हैन सो त्यो यो चिजहरू हैन इथिक्स बिहेभियरहरू दिस इज अल्सो भेरी इम्पोर्टेन्ट है सो अर्को चाहिँ रेजिलियन्स छ ल मेरो लास्ट स्लाइड हो एट द लास्ट के भन्छु भन्दाखेरि युनिभर्सिटीको गिफ्ट भनेको चाहिँ स्ट्रङ हैन फन्डामेन्टल्स स्ट्रङ एउटा लाग्ने तरबार बनाएर पठाउने हो राइट त्यसलाई कति धार लाउनुहुन्छ कहाँ गएर त्यो प्रयोग गर्नुहुन्छ हैन सो द्याट इज द थिङ अनि इन्डस्ट्रीको डिमान्ड भनेको चाहिँ पक्कै पनि प्र्याक्टिकल डिप्लोयमेन्ट प्रब्लमको सल्भ गरेको मान्छेले चाहिँ टुल्स एन्ड टेक्नोलोजीको पैसा तिर्ने होइन सोल्युसनको पैसा तिर्छ है सो त्यसैले गर्दाखेरि बी अ प्रब्लम सल्भर टुल्स एन्ड टेक्नोलोजी बेच्नतिर नलाग्नु है टुल्स एन्ड टेक्नोलोजी चाहिँ त्यो प्रब्लमलाई सल्भ गर्नको लागि हेल्पिङ ह्यान्ड्स हो सो त्यसैले गर्दाखेरि इन्डस्ट्रीले चाहिँ त्यो डिमान्ड गरिरहेको हुन्छ र त्यसको लागि चाहिँ पे गरेर हुन्छ क्या है र अनि अर्को चाहिँ डाइनामिक एडाप्टेबिलिटिज आफ्नो रेस्पोन्सिबिलिटिज है अब वर्ल्ड इज चेन्जिङ सो ऱ्यापिडली हैन यु क्यान नट नो लाइक अबको 10 वर्षपछि तपाईँले के जागिर खानुहुन्छ भनेर अहिले एक्सपेक्ट गर्न सक्नुहुन्न पहिला थियो हैन लयर भएपछि जिन्दगीभर लयर नै भइन्थ्यो अब त अहिले त डक्टर पनि आइटीतिर आउन थाल्नु भएको छ हैन डक्टर पनि इन्टरप्रेन्योरशिपमा देखिरहेको छु मैले हैन मेरो साथीहरूको जान हुनुहुन्छ हैन कम्प्लिटली हैन सो त्यसैले गर्दाखेरि अब यो बढ्दै जानेवाला छ घट्नेवाला छ हैन यु डोन्ट नो हैन आफ्टर 10 इयर्स वाट यु विल डु सो तर वाट एभर यु डु आर यु रेडी to learn yourself, update yourself, dynamic environment को लागि so त्यसैले गर्दाखेरि don't wait for the curriculum to change हैन हो युनिभर्सिटीको आफ्नो एउटा चाहिँ कहिले कन्स्ट्रेन्टहरू हुन्छ हैन साइज कत्रो छ चेन्ज गर्दा कत्रो हुन्छ युनिभर्सिटीको आफ्नो डाइनामिक चाहिँ नि कति समयमा चेन्ज गर्ने भन्ने हुन्छ हैन तर के हुन्छ भन्दाखेरि आफ्नो ह्याबिट त तुरुन्तै चेन्ज गर्न सकिन्छ सो त्यो सिलेबस कुर्नतिर लाग्नु हुँदैन सो द्याट्स माई फाइनल message for you so thank you for listening thank you very much
Thank you very much, sir, for your insightful and inspiring session. Your perspective is really valuable for our students and all our researchers. Let's again give him a huge round of applause. Now, marking the ending of the guest speaker session, I would like to call Engineer Dinesh Gothe sir, the head of Department of Computer and Electronics Engineering in Khopa College of Engineering and also the Secretary of Khopa Seal 2026 to present a small token of love to our speaker, Dr. Suresh Pokhrel, as a gesture of gratitude and respect. Thank you very much, sir, for being with us here today and sharing your valuable insights. Now, again, like slot 1, the technical sessions will be conducted in parallel venues. The electronics technical session will be held in Hall 2. So all the electronics presentators and participants are kindly requested to proceed to Hall 2. The electrical technical session will be held in Hall 3. All the electrical presentators and participants are kindly requested to proceed to Hall 3. And for the computer technical session, it will continue here in Hall 1. And all the computer paper presentators and participants are requested to remain in this hall. And we will begin the technical session shortly. Come, I said no. Everyone, please be seated and please maintain the decorum. We will be beginning shortly. We will now begin the technical session slot 2. In slot 1, we successfully witnessed presentations from 6 outstanding teams covering a variety of topics in computer engineering. Now in slot 2, we will continue with the next 6 teams presenting their research to detailed presentations. As with slot 1, each presenting team will be allotted 10 minutes for presentation. A warning bell will ring at 8 minutes and a final bell will ring at 10 minutes. And a 5-minute Q&A session will be led by our session chair. Now moving forward to our session chair introduction, we are honored to have Dr. Aman Shakya as the session chair for a slot 2 technical session. Dr. Aman Shakya is an assistant professor at the Institute of Engineering, Pluto Campus, Tribhuvan University, where he has been serving since 2011. He earned his PhD in informatics from the National Institute of Information under the Graduate in University for Advanced Studies, Japan. His research interests include semantic web technologies, interoperability, and data integration. Dr. Shakya has held key academic leadership roles and teaching courses in knowledge engineering, software engineering, web technologies, and database system. His guidance and expertise will ensure that the session will run smoothly and the presentators will receive valuable feedback on their research. Now, I'd like to hand over the technical session to Dr. Aman Shakya. So let's give him a huge round of applause.
Thank you very much. Thank you very much for the warm welcome and the wonderful introduction. Dear organizers of the Copper Seal, the corporate engineering colleges. Okay. So I am actually honored to be here as one of the program chairs in computer engineering. So I was looking at the list and we have at least 6 papers today, and I just got a correction. The first paper presenter would be Mr. Ravi Bhusal and not Mr. Sachit Neupane. So there's a small correction there. So I hope all the presenters are in the room, and I think we'll have an exciting session. We have multiple papers in machine learning, in applications in areas like disease prediction and image processing, and also music. So we also have papers on security, including blockchain and key management. So I am looking forward to this session. So without losing more time, so I'd like to call the first paper presenter. The paper title is Key Shard Distributed Password Management System. The presenter listed here is Mr. Ravi Bhusal. So you may proceed.
Good afternoon, everyone that are present in this conference. Today, me and my team are going to present on our project, a research project that is KeySART, a distributed password management system. These are the presentation outlines. And for the introduction, in the growing modern era, all the online services require password for the user to authenticate in the system. So the user needs to properly manage and properly needs to manage their password. So this is where a password manager comes in place. So the KeySART, a distributed password management system that uses ML-based password security management as well as distributed database. So for the problem statement, many password managers that are currently in the market utilizes a centralized database that has a single point of failure, and the current modern password managers cannot properly implement the zero knowledge encryption, where the zero knowledge encryption means that only the client side knows about the user credentials, while the server side doesn't know anything about the user information. And all the password managers currently use traditional rule-based password strength evaluation instead of machine learning techniques. Thus, the core research lies on successfully implementing the ML-based password strength evaluator, the distributed database, and faster and efficient encryption algorithms. So, for the methodology, we used a incremental process model, due to which we were able to iterate through our errors earlier on our projects, and due to which we were able to also implement the harder topics such as ML and distributed database and encryption algorithms earlier on our project. So for the algorithms, we used AES GCM plus ED25519 algorithm. The AES GCM is a symmetric key algorithm that is used for encrypting our vault, while the ED25519 is a digital signature-based signature verification algorithm. The ED25519 is used for authenticating the user by verifying the challenges using the signature. And the Argon 2ID is a 256-bit key derivation function, which derives a 256-bit key from the master password entered by the user. That key is used by the AES GCM for encrypting our vault. And the XCBoost classifier is a ML-based algorithm that is used to develop the ML password strength evaluation. And if the XCBoost classifier finds out that our password is weak, the SAP recommendation recommends which areas our password is weak on and how we can improve the password. And this is the methodology, where we can see that multiple number of nodes represents the distributed database. We have encryption decryption layer where the AES GCM algorithm takes place, that encrypts and decrypts the password vault, while we have a password strength evaluation. The XCBoost classifier works here. We have above that layer where all the CRUD operation takes place of the password, and for the user authentication, the Argon 2ID algorithm is used so that we can verify the master key. And this is the result and discussion for our ML-based model. We can see that we have 3 types of password levels: strong, medium, and weak. The strong password has a high true positive rate, while the medium and weak have decent type of true positive rate. So we can, and also the custom threshold used is 0.41, such that the weak password is more sensitive towards detection, because detecting a weak password as a strong password can be a critical failure. Thus, this is the result. And for the ROC curve, we can see that every area under the curve is above 0.9, which means that every difference between these types of password is properly separated. So this is also a good result. And for the evaluation, our distributed database have, on evaluating, we have no single point of failure, high availability, fault tolerance. And for the encryption, every encryption algorithms were tested, and no plain text storage is done, and authentication against tampering of the password. For the cost competitive advantage we have against the current systems is that we have high availability, eliminates centralized storage risks. We have zero knowledge encryption, where the zero knowledge encryption actually means is only the client side can derive what the user's information is, while the server side cannot read anything about the user. So that brings another layer of security. And for the simulating the distributed database, we have used multiple number of Docker instances. That is how it is done. And for the conclusion and future works, we have key achievements can be taken as we have 80.26 as macro average for 3 different types of passwords. AES, GCM, zero knowledge encryption can be taken, yes. And for the future works, there can be a blockchain-based audit logs for every action that is performed by the user. We can log using blockchain technology, multiple device synchronization, real-time database integration, and biometric-based authentication systems. These are the differences, and thank you.
So, thank you. So, I think the floor is open for question answers. So, from the audience, if you have questions, please feel free to ask. If you have questions, please raise your hand. I think the mic will come to you. Any question? Please do not hesitate to ask. So until the audience thinks of questions, so I have a quick question. So what would be the deployment requirements or deployment environment that would be needed to implement your project or your proposal?
Deployment environment as in?
Yeah, what infrastructure and what technologies would be required if I wish to deploy this system, distributed password management system in real world?
We are working on, main is Monstack only. Then for the database, we have Go-based, database written in Go, our own database, key value storage. And for the rate limiting, we have used Redis implementation. Front end is, it is a mobile application, so front end we have written in React Native, and back end in Node.js, that is it. And for the algorithms, algorithm libraries, that is particularly AES CCM algorithm library, ECD, EDC 25519, and Argon2ID, HKDF algorithm, that are the requirements.
So it's feasible for implementation in a medium organization setting?
Yes, medium to large it can be implemented, because due to the distributed database, it is very scalable. And yes.
So any question from the audience? Please raise your hand if you have questions. No? So let me ask one more question that I have. So usually we have seen systems that suggest based on different rules what a difficult password should be. Like having capital letters or special character or not being the previous password and so on. Right?
Yes.
So have you compared your machine learning output with some existing systems with rule-based approaches for securing the passwords?
Yes. The rule-based usually show a better result when there are multiple number of characters or longer password are there, then they show good results, but ML can identify the repeated characters or repeated items, so it is probably better than the rule-based evaluation. And yes, our ML is usually based on entropy, so the more the randomness, more the higher result.
Okay.
Better result.
But in the meantime, another factor is how much you can remember the password. If it is too hard password, perhaps you will need another vault to store the password, and you will have another password for that vault as well.
Yes, but the main password is only important, the master password.
Okay.
That needs to be saved correctly.
Okay. Any more questions? If no other questions, then let's thank the speaker and the authors, and we'll move on to the next presentation. Thank you. So the next paper to be presented is Multiple Disease Prediction System, MediPredict. The presenter listed here is Ms. Sunidhi Dahal. Ms. Sunidhi, are you here? So you will have 10 minutes for presentation.
Good evening, everyone. My name is Sumika Rai, here with my friends Ayusha, Sunidhi, and Sumira, here to present our presentation on multiple disease prediction, MediPredict. So this is the brief overview of the topics we will be covering today. So as we know, healthcare system nowadays generate a large amount of medical data, but early disease detection is still a problem due to time, cost, and limited access to specialists, especially in rural areas. So to address this problem, we have created a web-based system that predicts the risks of 3 major diseases: Parkinson's, heart, and diabetes. So traditional medical diagnosis struggle with complex data, which leads to slow processing and higher costs. And regular health diagnosis is also very expensive, time-consuming, and not readily available, especially for the people in remote area. So we have created this system to predict our 3 major diseases with a very simple and user-friendly interface. So we have used incremental model for our project. For analysis, we identified the requirements. For design, we designed the system with a user-friendly interface. For code, we trained the model using Python script, and for testing, we tested the functionality and ensured the system quality. So this is the system block diagram, where the user first interacts with the web interface, where the user can input the data and also choose the model. It then goes to the main application. It then goes to the input validation, where it checks the validity of the input data and also converts the data into numerical form. Here, the pre-processing is also done. It then goes to the main application controller, which controls the overall flow of the system. So here are the 3 modules, which was trained using the pre-processed data. And then after that, after the prediction, it goes with the prediction model, which overall gives the final output. So for result, I would like to call Sunidhi.
So this is the result of our project. So we have focused on 3 diseases: diabetes, heart disease, and Parkinson. And for algorithm, we have used random forest algorithm for all the 3 diseases. So I'll be explaining this table in the further slide. So here, as we can see that we have used 8 features for diabetes, among which glucose is the main contributing predictor with the importance score of 0.27. And for heart disease, we have used 11 features, among which the ST slope is the main contributing predictor with the importance score of 0.19. And for Parkinson's disease, we have used 22 voice features, among which PPE, pitch period entropy, is the main contributing predictor with the importance score of 0.25. So coming back to this table, For result and performance, we have focused on accuracy and ROC AUC. So as we can see here, for heart disease, our AUC is 0.97, for diabetes it is 0.82, and for Parkinson it is 0.94. So these are the three confusion matrices for our three diseases. As we can see that the false negative for all the three diseases is very low. That is, for diabetes, our false negative is 22. For heart disease, it is 6, and for Parkinson, it is 3, which represents less misinterpretation and results in the accuracy of 94, 93, and 93% respectively. So in conclusion, we have used single optimized random forest algorithm, which helped us in achieving high accuracy. And for our future work, we can add other diseases in a single interface, and also add recommendations for the precautions of the diseases. So these are our references. Thank you for your time and patience.
Okay, thank you. So that was a quick presentation. So I think we have enough time for questions. So please feel free to ask. So if you have any question for the ladies, so I believe most of the audience are your friends. That's why they are not asking questions. So they are your friends, so you should be, you should feel free to ask questions. I believe most of the people here are undergrad students, so this is also part of learning, so you can feel free to ask questions. So don't be afraid to ask questions, you can ask anything you like. Anyone who is not shy to ask questions? Let me ask few questions until the audience thinks. Can you show the features, input features? I believe you showed multiple features for different types of diseases, right? So can you elaborate a bit how these features are obtained? Are they derived from some medical history or from some measurement? So can you elaborate?
So in feature importance, we have considered the report that we get from the medical record. We have gone to civil hospital for inquiring these parameters. Over here, for diabetes, the main factor was glucose and BMI. We use Guinea impurity to detect which one of the split is more essential for our project in algorithm. At the same time, for heart disease, we use ST slope and chest pain. These were the factors that were considered by doctor. And one of the references for it was also...
Okay, I think you didn't get my question. So this shows the importance of the features, but I was asking how these features are obtained in the first place.
It's from medical records.
Sorry?
Medical records, the data sets we had.
Okay, but do you have any idea how such data sets are made if you have to make your own data set from scratch?
Actually, we took it from Kaggle, so we don't know much about it. But if we want these data sets are of patients for the records of after they are being treated.
Okay.
It's more of like predicting
Yes.
for classification.
Because I see some data, some of the parameters may be constant or fixed
Some
for a
of the
certain time, like
parameters-
AS6 and maybe chest
Okay.
pain type,
Yeah,
or certain maybe over a period of time, like cholesterol or heart rate.
Yeah.
That
Some
varies,
of these parameters are usually A's and sex are very much common, but other parameters, they do need medical reports and everything. So these parameters are usually obtained from medical reports.
So any more question? Any questions from audience? And I think we have a lot of approaches in predicting or classifying diseases. So have you studied other approaches in literature and tried to compare your approach with other approaches for classifying or predicting diseases?
Yes, we did that. We did that quite a lot. The thing is, while considering the medical records, we have to consider consistency of the data. The medical records were non-linear, so when we consider logistic regression, non-linear could not be done on that. For SBM that we considered, we used kernels and all, not very appropriate for us. And for XGBoost, we had a very limited data set. Medical records are very hard to gain. That's why random forest was the most appropriate one. Over here, we had like decision trees well, ensembling and everything, and had Guinea impurity too, so that the mean feature importance was selected in a way. So this was more of a finalized algorithm for it.
Do you have some quantitative comparison between different approaches?
Actually, we did had it in our report, but we haven't presented it in the presentation. We're sorry about that.
Okay, no problem. Any question? So if no questions, then we'll move on to the next presentation. So thank you very much for the
Thank you.
presentation. So the next paper in the list is a GAN-based comparative study for high-fidelity celebrity image denoising. The presenter is Nishtal Mainali. Are you here? Okay. Okay, so you'll have 10 minutes for presentation.
Hello. Okay, good afternoon everyone. So the topic of our presentation is GAN-based comparative study for high fidelity celebrity image denoising. So let me begin. So these are our 6 slides available for today's presentation. So introduction. So why was this project selected? So low quality and degraded images remain a major challenge in real world computer vision applications. This means that for various video editing purpose or other celebrity images posting in social medias and other platforms, the problem of low quality images is prevalent. Traditional methods are not able to restore the fine and sharp details of the images. And with the introduction of newer and more modern technologies, it has made possible to make the denoising of images sharp and more refined. So we have taken a GAN-based framework approach, leveraging DGAN, SRGAN, ESRGAN, and CGAN to denoise celebrity images. So our problem statement is, many celebrity images are available online are compressed to save storage. And during the process of transfer and posting, the resolution of the images gets lost. A lot of unnecessary noises also get added and the images can be blurry. Traditional enhancement techniques use interpolation and Bayesian filtering methods. These are usually mathematical models, so the accuracy of the facial structures and the sharp edges may not be always reconstructed properly. So deep learning based solution using GAN models could solve this problem. So here's our methodology. First we used noisy images in our model and trained the model to denoise them. We used a GAN, generative adversarial network, which means that the model itself trains itself and provides all the necessary loss functions to generate a clean image. Here we used 5 types of noise to model our images: Gaussian noise, salt and pepper noise, speckle noise, Poisson noise, and uniform noise. So here's the basic framework of GAN. So it has a generator, discriminator, and the generator produces enhanced image, while the discriminator distinguishes between real and generated image. If the discriminator cannot judge the image as real or that generated by generator, then the image is passed. Otherwise, discriminator distinguishes that the image was fake and the generator is trained again. So it uses adversarial training, meaning that discriminator acts as a barrier in model training. So the GAN models we used were DGAN, strong denoising capability. DGAN was denoising GAN, which we developed ourselves and trained ourselves, while SRGAN and ESRGAN are pre-trained models which we use to compare our model. And CGAN, conditional and control generation, it was also a type of GAN that we used to test our model. So the evaluation metrics that we used are PSNR, SSIM, MSSSIM, LPIPS. So what are these evaluation metrics? PSNR is used to measure the pixel accuracy. It takes the real image as well as the generated image and checks the pixel accuracy, while SSIM measures luminance, contrast, and structural similarity. So for both of these parameters, it is better to have a higher value. So for our LPIPS, it compares the deep feature similarity. So in this case, lower LPIPS means better perceptual similarity, while MSSIM evaluates similarity at multiple scales. So it helps to determine better structural evaluation. So here's our result. We compared the 4 models of GAN and found these data on the evaluation. So these data are summarized here in the metric table. What we found out there was that denoising GAN or DGAN performed the highest among these 4 models. So CGAN had a PSNR level of 26.5, SRGAN had 18, ESRGAN had 26, while DGAN maintained a high value at 32. So for all of these parameters, denoising GAN performed the most excellent, and it had a very early convergence, meaning that while training less, it performed better. So noise removal efficiency was also very high for denoising GAN. So in conclusion, we can say that all of these 4 GANs can enhance low resolution celebrity images, but the proposed deep learning approach outperforms traditional methods in restoring fine details and preserving identity. DGAN reduced noise and distortions the best, while ESRGAN produced the sharpest and detailed results. SRGAN improved perceptual quality, while CGAN enabled more control and condition-based image generation. So all of these models each had their own advantages. For future work, we could integrate color enhancement, lighting normalization, and contrast adjustment. Here in this project, we have only focused on noise, reducing the noise and removing the noise. And we could extend the system to general image datasets beyond celebrity images. So here are our references. So thank you.
So thank you for the presentation. So we have good time for questions. So from the audience, if you have questions, please feel free to ask. I think there should be some points for asking questions. So first I have a stupid question. So, you mentioned celebrity image denoising from your title. So,
Yes.
Is there some specific reason why you want to work for celebrity image denoising? Wouldn't this approach be applicable for any type of image denoising, or is there any specific challenge in celebrity image denoising?
Celebrity images are basically available in internet everywhere, and we can extract those data easily, as we have many data sets also freely available for them. So we choose.
Oh, so the reason is data availability,
Yes.
not specific challenge regarding celebrity images.
Yes.
So question from audience. You may raise your hand like this. Yeah, at last one hand up. You'll have the mic. Yeah.
This is hello. Like, are there any examples that we can see about like how it really performed, and how much does it like preserve the natural features when the images are denoised?
Well, there are not any examples available here. We have not presented that. So talking about the features, there are some evaluation metrics that we used in our final web product that shows how much the images are similar to a real one or original one, but due to some factors, we are not able to show that here.
Okay, hope it answers. Any more questions? So if you ask question, you will be on the TV. You can answer. Okay, last question.
म गाह्रो क्वेसन सोध्दिनँ मेरो नाम चाहिँ सुरेन्द्र केसी डिरेक्टर अफ इन्जिनियरिङ इन्फाइनाइट नेपाल मेरो क्वेसन चाहिँ लामो छ एन्सर चाहिँ एकदमै बाइनरीमा हुनसक्छ है जस्तो तिमीले सेलिब्रिटी इमेज जुन डिनोइज गर्ने नोइज इमेजको नोइज रिमुभल गर्ने कुरा गर्यो यसमा रियल वर्ल्डमा यसको युज केस भ्यालु त्यति नदेखिएला तर जस्तो म चाहिँ हेल्थ केयर कम्पनीमा काम गर्ने भएको भएर नर्मली हेल्थ केयर इकोसिस्टममा चाहिँ वी रिसिभ मेडिकल रेकर्ड्स के हाम्रो फाइल हुन्छ नि हिस्ट्री डक्टरकोमा जाँदाखेरि अनि देयर आर नम्बर अफ पेजेसहरू हुन्छ त्यो पेजेस चाहिँ कुनै राम्रो हुन्छ कुनै नोइजी हुन्छ कुनै करप्ट हुन्छ डिफ्रेन्ट काइन्ड अफ नोइज त्यहाँ बसेको हुन्छ क्या र हाम्रो लागि एकदमै फर्स्ट च्यालेन्ज भनेको चाहिँ त्यो नोइजी इमेजहरूबाट तिमीले भने जस्तो नोइज रिमुभ गरेर हाउ इफेक्टिभली वी रिट्रिभ द्याट काइन्ड अफ इन्फर्मेसन फ्रम द पर्टिकुलर मेडिकल चार्ट भन्ने चाहिँ एकदम च्यालेन्जिङ हुन्छ अब तिमीले गरेको युज केस सेलिब्रिटी इमेजको नोइज रिमुभ गर्नेले रियल वर्ल्डमा त्यति भ्यालु नहोला तिमीलाई फन क्रिएट चाहिँ होला होइन रमाइलो होला तर तिम्रो यो आइडियालाई चाहिँ मैले भनेको कुरामा रिलेट गर्न सक्यो जब तिमीले कुनै पनि आइडेन्टिफाई गरेको आइडियालाई रियल वर्ल्ड प्रब्लम सोल्युसनतिर तिमीले अलाइन गर्न सक्यो भने तिम्रो आइडिया चाहिँ अलिकति इम्प्याक्टफुल भएर जान्छ यही केसमा चाहिँ आन्सर अहिले भनिहाल्यो होइन हाउ कन्फिडेन्ट यु आर के तिमीले अहिले गरेको एक्सपिरियन्स अथवा हार्डवर्कको आधारमा अहिले मैले भनेको सिनारियोको केसमा पनि स्केल अप गर्न सकिन्छ यो आइडियालाई चाहिँ त्यहाँ पनि हामी नोइज रिमुभ गर्ने डिरेक्सनमा चाहिँ हाम्रो हार्डवर्क चाहिँ इफेक्टिभ हुन सक्छ भन्ने कुरामा कति कन्फिडेन्ट छौ तिमी
सर यो क्वेसन चाहिँ एकदम राम्रो हो सर किनभने होइन अहिलेको मेडिकल सेक्टरमा इमेजिङ भनेको चाहिँ एउटा मोस्ट इम्पोर्टेन्ट फ्याक्टर हो कुनै पनि डिजिजको सिम्टम थाहा मात्र होइन त्यसलाई डायग्नोस गर्नलाई अब यसरी नै हेर्दा जाँदा ज्ञान मोडल भन्दा पनि अहिले एडभान्स मोडलहरू पनि आएको छ कि सर त्यो चाहिँ डिफ्युजन मोडलहरू भन्ने यसमा चाहिँ रिसर्च कन्टिन्यू भइरहेछ त्यसले चाहिँ अलिक मोर एकुरेट रिजल्ट दिन सक्छ कि भन्ने जस्तो लाग्छ क्या मलाई चाहिँ यो इमेजमा किनभने ज्ञानले चाहिँ अलिक प्रेडिक्ट गर्ने हो र यदि जस्तै इमेजिङ मेडिकल फिल्डमा चाहिँ अलिकति रङ प्रेडिक्ट गरिदियो भने फेरि त्यहाँ दाग नभएको ठाउँमा दाग देखाइदियो भने चाहिँ अलिकति केयरफुल भएर त्यही भएर यस्तो एआई मोडललाई नि मेडिकल फिल्डमा चाहिँ अलिक केयरफुल भएर एप्लाई गर्नुपर्छ जस्तो लाग्छ त्यही भएर यसमा चाहिँ अलिक रिसर्च पनि धेरै र आफ्नो पुरै मेहनतै लगाउनुपर्छ अलिक केयरफुल भएर गर्नु
थ्याङ्क यू किन मैले तिमीलाई किन सोधेँ भन्दा नेपालमा बेस्ट युएस कम्पनीहरू प्राय युएस हेल्थ केयर एनालाइटिक्स कम्पनीहरू नै छन् मेजर कम्पनीहरू त्यसमा चाहिँ तिम्रो आइडिया तिमीले प्लान गरेको आइडिया र तिम्रो अप्रोच लिएर गयो भने सजिलै तिमीलाई भोलि बिहान इन्डस्ट्रीमा जोइन हुन पनि सजिलै होला अन्त जोइन भएन भने मलाई सम्पर्क राखेको नि हुन्छ है ल थ्याङ्क यू
थ्याङ्क यू सर
So thank you. So very useful, valid comment from the audience. So we'll move to next presentation. The paper title is Deep Learning Based Music Score Separation for Newari Traditional Instruments. Presenter is Anish Shilpakar. Are you ready with the presentation? I hope we'll have your slides soon.
Hello. So, good afternoon everyone, respected teachers. So, today we stand here to present our research topic, which is music source separation for Newari traditional instruments. So, this is our presentation outlines. So, moving on to the introduction. So, music source separation is a smart technology which is used to separate mixed music sources and pull out the only one instrument from this mixture of the instruments. So here we are planning to work on 3 individual traditional instruments, which are basuri, khing and theme. So when the music instruments are provided as an input, then all the instruments are blended together. So it is one kind of a challenging thing. So moving on to our problem statement. So what we have found here is there is a huge resource gap in this field yet to be explored, which is there are different models available for the music separation, but not for the solely based for the Newari instruments. So they are currently for the Western. There are currently different models working for the Western instruments like guitar, violin, but yet to be explored. So this is a kind of a new thing to be explored. So another one of the main problem statement that we have found here is there are lack of data sets for this field to be explored. So it is kind of a new challenging thing, and also there are no gender models that can correctly recognize the unique timbreness of the Newari instrument. So our objective is to create this kind of system that would help to preserve our Newari music heritage. So for the methodology, we have approached 3 unique architectures. One is unit architecture, another is a GAN one, and another is the ensemble of these 2 architectures. And we have tested on the we have benchmarked our models on this available data set. So for first, moving on to the collection of the data set, we have collected 800 samples each of 3 basuri, theme and khing, and created a incoherent mixing from these samples that we collected, and then the total audio samples that was available was around 2400 samples. So as we know, for the deep learning models, it is not quietly enough for training our models. So what we have approached is we augmented the collected data set by different augmentation techniques, as we can see here. So moving on to our first approach, which we have used is a unit model. So in unit model, what we have used is there is a mixture of an input that are provided, right? Then it is converted to a complex spectrogram, which is achieved by the inverse short time Fourier transform. So why complex spectrogram? So it helps to preserve phase and magnitude both, which can be used for the training later on for the models. So in our after the complex spectrogram is achieved, it is passed to our unit models, where there is 3 main architectures, transformer, which are encoder, then our transformer bottleneck and unit. So in our transformer bottleneck, there is 2D positional encoding and self-attention aid, so which helps to capture the previous and later on music segments. So then it is passed to the decoder for the desampling, and finally we can get the multi-source heads as an output, where we can get 3 heads from the output. And finally, performing the inverse short time Fourier transform, we get the music source. Moving on to our another approach, which is GAN model. Here we have used a cycle GAN. So the approach here for the input spectrograms are all same, where the change lies is in the core architectures. What we have used is a cycle GAN architectures. So in GAN, as we know, there is two main blocks, where this is generator and a discriminator, which are trained parallelly, and their core objective is to beat one another. So what we have done here is the complex spectrogram is passed to the generator box, then we can finally get the three separated heads from the generator output, and then it is passed to the discriminator, where there is a multi-scale patch discriminator, and which will be detecting the real and fake generated of the output samples. So from them we can get the feature mappings and output. And then finally we also tried a novel approach, which was the ensemble approach, in which we try to combine the weights of two unit and our pretrained GAN models to see how the outputs will change. So surprisingly, it was a great achievement, though we have trained for less epochs in this approach, but we get a fine outputs improvement in this. So here, what we have done is, we have introduced some meta models by just ensembling the previous models and get the adaptive waves and get the outputs. So here are the results and discussions that we have found in each of the models. It's like a comparison tables for these three models that we have used, though ensemble has not been trained enough. The main our focus will be on enhanced GAN and enhanced unit. So what we have achieved is our matrix here is signal to distortion ratio, which can be also known as SDR. So in the validation data set, what here is we have achieved in unit GAN is around 13 dB, which is quite impressive, and in enhanced GAN we were around achieving 8.3, and also in ensemble we have achieved around this kind of approved. So we have also did benchmarking of our data set in our own test data set and our SDR and MUSDB 18. So here is the comparison tables. The below one is the model evaluation comparison on test data set, and above one is on the validation and benchmark data set side by side. So this is the training. Though the training has been just performed for around 20 epochs, but we can see here the achievement for the graph is quite impressive. So here in the loss curve, the train and validation are overlapping each other. So it is quite impressive, and we can see here, if we go on and train for further more epochs with enhanced more number of data sets, then obviously we will achieve more improvement in this. And then in the graph here, for the first graph represents the discriminator and generator trying to beat each other. Then another one is the validation SDR, where we have achieved around 8.2 around, and then for the generator loss component, we can see that there is a significant loss in L1 construction and adversarial loss, which is a quite impressive one. So, and this is the final output. When the original output here, we can see that there are two different spikes, right? One is vertical spike and another is the horizontal spikes in the spectrograms. So this is our spectrograms, which will be passed on to the models, and when we get the final output, we can see that the original mixture was of Basuri and Teme combined. So after it was passed to the models, we can get two different separated outputs. Which one is Basuri and Teme. So in spectrograms also we can see that for the Basuri one, there are horizontal spike present. So we can conclude that, right, the original spikes represent the Basuri one, and for the Teme one, there are horizontal spikes. So this is obvious that Teme are quite large sounding, so this like this. So for the conclusion, yeah, we have tried some novel approach in this field, so but there are different expansion and enhancement remaining, which are on data sets, resource constraints, and due to resource constraint and time constraint. So yeah. These are the references, and thank you.
So thank you. So thank you, very interesting work. I think this would be a contribution for the local culture and instruments too. So I believe the audience should have questions now. Yes.
So hello. So have you considered the scales of Basuri and all other instruments? Like I've seen you have been mixing the instruments. So we have different scales of instruments, right? So have we merged them, or we have just considered Basuri is of same scale.
So, yeah, firstly, we collected the samples for individual Basuri, Dhime, and King, right? 800 samples. And we have also done the incoherent mixing. So, for this, we have mixed the collected data sets, and those are also passed to the model.
Okay, thank you.
Are there more questions from the audience? So,
okay, could you please explain some of the high-level differences that might be in different audios of Basuri and other instruments that model might have learned?
So from the spectrogram also we can differentiate that the Dhime and the Basuri and other instruments have the different spectrogram. As we can see from the spectrogram plot, which is a log spectrogram plot. So generally melodies are represented in the horizontal spikes, whereas the bass are represented in the vertical spikes, and the melodies have the higher frequencies, and whereas the bass have the lower frequency range. So that's how the model separates it.
are there more questions from the audience? I think.
So like this is like very, very hard to understand. Are there any other kind of matrices that we can like easily like visualize the differences in these sounds?
For the sounds, it is in a logarithmic scale. So there is no like scale. There is no visual representation of the sound that we can like visually analyze it, but through the hearing, as our ears work, that is a logarithmic scale. Through hearing, we can like perceive the different sounds, but not in the visual representation. For the visual representation, the spectrogram approach is the most efficient and the most widely used approach. And there are other approaches in the spectrogram. There is like, this is a log spectrogram, where there are the mel spectrograms and magnetic spectrograms and the power spectrograms as well. But for like separation tasks, we generally use the like logarithmic scales because it has it accounts the higher frequency beams, whereas in the mel spectrogram, they can be used for the classification or the like audio recognition, which use the mel filter banks, which is very similar to how our ear perceives the sound. So you can check out the mel spectrogram for the like classification and the audio recognition. But whereas for the separation, you have to the log scale spectrogram is more efficient, I guess. Okay, any more questions?
So perhaps we have time for only one quick question, if anyone has. Any question? If not, one quick question from me. So I understood that you mixed different tracks to get the mixture, right?
Yes, sir.
And did your experiment based on that. So have you tested your approach on real orchestra or real time playing where they are playing together, not artificial mixing?
Okay. So during training phase, right? So we firstly collected the data. We did different augmentation to handle these different scenarios. And during testing, we actually used a real test data set. Like we also recorded some of our own and also took some of the playlists from the YouTube and tested on those as our test data set.
Okay, thank you. Thank you, interesting work. So we'll move to the next presentation. The title of the next paper is Meta-LoRa, Establishing Reproducible Standards for Dynamic Rank Allocation in Parameter Efficient Fine-Tuning. The presenter listed is Mr. Ashish Pandey.
Every practitioner working with LoRa faces the same frost-taking decision. Which rank do I choose? You pick 4, 8 or 16 and then you run the experiments. And then you choose the one that works. and hope when we change the hardware, it works still. So that's a guessing game. So what's the solution? So we present you the Metalora. As it's very hard nowadays to train fine-tune the model, as they are growing rapidly, fine-tuning has been almost impossible for normal researchers, and LoRa has become a go-to method for adaptation. And the equation is just elegant, but in this elegance, there is a hidden bug hiding in hindsight. It has many complications. LoRa relies on arbitrary threshold, and it works for static or manual but not dynamic, and it does not provide formal memory guarantees for the memory budget, and it is very difficult to produce across hardware. So we started with a simple research question. Can we establish a reproducible standard for dynamic rank allocation with formal memory guarantee? The keyword here is formal memory guarantee. So the answer is Metalora. Here we do important estimation by sensitivity-based calculation via gradient to identify critical adaptive layers to find the work. Then we do constant optimization using mathematical principle allocation, using Lagrange multiplication and binary search. Then we use exhaustive calibration. We have done rigorous validation across 4,400 configurations to ensure sub 1% prediction error. So first the system takes the input, then it abstracted feature, then it goes into the network, then the Metalora, it goes into the Metalora, and then we get the LoRa configuration with the rank, modus and alpha before even the training begins. So importance here I is the important calculation which represents graduated product as a proxy for sensitivity, and it has been high algorithm stability across 5 random seeds, and it has validated across 3,17,160 total samples. This is the method of optimization flow, where it moves beyond heuristic to the mathematical principle framework for rank allocation. First we start then extract the features, then we do embedding and casting order, then meta-controller predicts, then apply top LoRa config, then we train and evaluate. Then once we get best performing parameters, we return to optimal configuration. If not, we go back, and this is the flow we have designed. So we have done exhaustive, as we have mentioned that we have done exhaustive calibration for it. We have done 4,400 unique configuration tested, and we have got sub 1% prediction error in memory usage, which is huge. And we have identified optimal hyperparameters for GPT-2. And to prove it again, we have done rank allocation, just using FFN only, attention modus and combination of both. And from there, here's the key takeaways. Principal standard for dynamic importance estimation, guaranteed memory against via Lagrange optimization, and statistically negligible variance across diverse constraints. And the future direction is we have just tested one module GPT-2. Extension into trillion parameters and multitask dynamic allocation strategy and real-time adaptive rank shifting during inference. And this is the reference. And we have provided all the codes, logs, and everything on the GitHub for open source and for 100% reproducibility. And if you guys have any question, you can reach out to us via email. Thank you.
So I think the audience can directly reach you here. So if there are questions, if there are any questions from the audience, please raise your hand. If not, let's ask you one simple question. So, can you describe where such low rank adaptation or your algorithm would be applicable or needed?
Basically, while choosing the rank, we generally choose 4, 8 or 16 and then choose after doing the experiments. So, but it works on one hardware, but when you switch the hardware, there are multiple cases that it won't work. So, for that, we use this.
Okay, so can you show the comparison of LoRa and Metalora and other other similar algorithms?
Yeah, we don't have the comparison right now, but I can say you the answer. It's SOP5 QLoRa or other method, AdaLoRa, but the issue here is they doesn't provide formal memory guarantees, and this method provides the formal memory guarantee. That's the difference. We are not playing on accuracy or this. We are trying to do 100% reproducibility every time people use it. Like there might be better papers that are better accuracy or those things, but they doesn't provide memory guarantee that we do.
Okay. Any question from the audience? I think no more questions. So let's thank the authors. So thank you. We'll move on to the last presentation of this session. The last paper is titled Behavioral Anomaly Detection in Blockchain Voting System. The presenter listed is Isha Bhatrai. Please come forward.
Hello and a warm good afternoon to everyone present. Respected session chair, distinguished guests and fellow researchers, I am Jimmy Shrestha and I'll be presenting our paper titled Behavioral Anomaly Detection in Blockchain Voting System on the behalf of my team. So I'll structure our presentation into 6 parts. We'll start with the introduction, then move through problem statement, methodology, results and discussion, conclusion and future work, followed by the references. Let's start with the introduction. So electronic voting system based on blockchain technology has been gaining a lot of significance due to its inherent transparency, tamper resistance and other properties, but most existing systems focus on cryptographic integrity but overlook other irregularities such as behavioral integrity as well. So this was the research gap that we decided to work on. So our project integrates machine learning based anomaly detection with blockchain to enhance election resilience. So to state the problem more precisely, blockchain system and voting system can exist having cryptographic security but still lack behavioral monitoring mechanism. So current design do not detect coordinated manipulations like abnormal voting patterns and transaction flooding. So without this analysis, the behavioral pattern which the human detects is a major problem in the voting system. So we have made a system to mitigate this issue. Moving on to the methodology, so you can see the framework of our system. We have integrated a private Ethereum blockchain with isolation forest to detect behavioral anomalies in real time. But most importantly, one of the most important features of our system is that our system does not reject any vote. Rather, it classifies the vote into from normal to extreme level, and the system administrator can determine if they want to keep the vote or reject it. So our system consists of a blockchain network, which is a private Ethereum network using Get 1.13 with click POA consensus. We have used POA instead of POW, as POA is faster as it can produce 5 blocks in 5 seconds without blockchain overhead, and smart contract enforces 1 vote per address at EVM level. When the people or the voter casts the vote, the features are extracted like voting time, intervote intervals, gas fee, block number patterns, participation deviations, and login attempt, etc. These features act as an input for our anomaly detection system. So for anomaly detection, we have used isolation forest. We have trained the isolation forest on stimulated voting data. It then isolates anomaly by partitioning the data. It detects unusual patterns like double voting, rapid votes, geographic inconsistencies, etc. Then our votes are classified and mapped into 5 levels from normal to extreme. All the votes and anomaly flag are stored in the database. So, moving on to the results and discussions, isolation forest. So, I have already said that isolation forest was evaluated on stimulated data to detect anomalous voting behavior. So, you can see clearly in the figure of the distribution of anomaly that the blue part, which is the normal behavior, and the red part, which is the anomalous behavior, is clearly separated. The blue part is more towards the positive side, whereas the red part is more towards the negative side. So these are the results from our model. You can see that the precision, recall, F1 score, specificity, and balance accuracy. So, in conclusion, I'd like to say that our project has integrated behavioral anomaly detection into the blockchain voting system, enhancing the security beyond traditional cryptographic measures. So, for future work, we will expand our system in both scalability and adaptability, and introduce other models to increase its accuracy. So, these are the references from where we have fill the research gap. So thank you, and you're welcome for any questions.
So, thank you. So, are there questions? Are there questions from the audience? If you have questions, please raise your hand. Yes.
Hello. My question is on anomaly detection. You talked about double voting, quick voting, etc. So let's suppose there are 2 scenarios. Case 1, there is a village where no internet access, nothing, totally bichhadiyeko kshetra. I, as an electoral volunteer, go there, convince 100 residents to cast vote. They cast vote from my laptop, from same geographical area. Case 2, I myself cast those 100 votes instead of allowing them to cast vote from again same my device from the same geographical area. Tell me, is your system able to differentiate these 2 scenarios? If yes, how? Also, if you are to use cameras to, facial identity, to detect facial identity to ensure unique votes, nobody wills to compromise their privacy for something like election. And if you are to calculate timestamps, time can be manipulated as well. So my question is how your system tackles this.
I would like to answer your question. So based on what I understood through your question, I can answer in Nepali, right? So,
yeah, you feel comfortable. Nepali ma answer garda pani huncha.
Okay, thank you. So like voting system त भन्यो anomaly भनेको एउटा फ्याक्टरमा मात्र हैन कि मल्टिपल कम्बिनेसन अफ मल्टिपल फ्याक्टर्स गरेर हामीले anomaly डिटेक्ट गर्ने हो. फर एक्जाम्पल तपाईले भन्नुभएको जस्तै एउटै डिभाइसबाट एउटै मान्छेले मल्टिपल भोट गर्यो, टाइम स्ट्याम्प पनि म्यानिपुलेट गर्यो, जियोग्राफिकल एरिया चाहिँ एउटै भयो. सो हाम्रो लाइक 4 वटा क्याटेगोरी छ अहिलेको लागि. एउटा मान्छेले मल्टिपल भोटिङ एटेम्प्ट गर्यो, त्यो भनेको एउटा रिस्क फ्ल्याग भयो, त्यसमा चाहिँ रिस्क स्कोर +2 हुन्छ. अनि त्यसपछि एउटा जियोग्राफिकल एरियासँग मिसम्याच छ कि छैन त्यो पनि हेर्छ. यदि मिसम्याच छ भने रिस्क फ्ल्यागमा अझै बढ्छ +2. अनि अर्को भनेको भोटिङ बर्स्ट भन्ने पनि छ. सर्ट टाइम फ्रेममा एउटै डिभाइसले मल्टिपल भोट एटेम्प्ट गर्यो भने त्यसमा पनि फ्ल्याग ट्रिगर हुन्छ, रिस्क फ्ल्याग +2 भयो. अनि तपाईले भन्नुभएको फेस रिकग्निसनमा प्राइभेसी इस्युज हुन सक्छ. लाइक हामी भोटिङ गर्न जाँदाखेरि नि त यति नै जान सक्छौँ. प्राइभेसी इस्युजलाई हामीले कसरी मेन्टेन गर्न सक्छौँ भनेर आजभोलि त सबैमा NIN नम्बर त हुन्छ नि त. NIN नम्बरमा अभियसली देयर इज बायोमेट्रिक डेटाहरू पनि हुन्छ, फोटोहरू पनि हुन सक्छ. इफ वी इन्कर्पोरेट द्याट फिचर इन्टु आवर भेरिफिकेसन मेकानिजम, आई थिङ्क यो प्राइभेसी इस्युज कुड अल्सो बी सल्भ इन द्याट वे. थ्याङ्क यू.
Thank you. Hope that answers the question. Are there more questions? Please raise your hand if you have questions. So this is the last paper, so this is the last chance for asking questions and coming on the TV. So if you have question, please ask. And we are having elections soon, so I think people are serious about election. So they are taking your paper seriously.
As well.
के छ क्वेशन्सहरु नेपालीमा सोध्दा पनि हुन्छ ब्याक
So this may be a silly question, but I was a bit confused regarding the main use case of this system. So like, are you doing anomaly detection as an analytics project, or are you integrating it in, a real-time use case scenario?
So our main focus is to detect anomaly in voting mechanisms, but we have implemented that by adding blockchain to it. हामीले blockchain किन भन्नाले blockchain को एउटा most widely known feature भनेको immutability हुन्छ हैन. Voting mechanismहरुमा कतिवटा भोटिङहरु त लाइक as we know नेपालमा हुन्छ नि डुप्लिकेट हुन सक्छ अर ट्याम्पर गरिएको हुन्छ. ट्याम्पर प्रुफ को लागि हामी ब्लकचेन गरेको हो, तर हाम्रो लाइक मेन एआई को पार्ट भनेको चाहिँ एनोमली डिटेक्ट गर्ने. अब ब्लकचेन भोटिङ मेकानिजम हामीले अब अनलाइनमा शिफ्ट हुन्छ, इलेक्ट्रोनिकमा शिफ्ट हुन्छ भने त्यहाँनिर पनि अब लाइक ट्याम्पर त हुन सक्छ. त्यसलाई नहुनलाई एनोमली डिटेक्ट गर्न सक्छ. त्यो एनोमली डिटेक्ट कसरी गर्न सकिन्छ भनेर नै हाम्रो रिसर्च ग्याप आइडेन्टिफाई गरेर त्यसमै काम गरेका हौं.
So like पछि गएर चाहिँ यो हाम्रो रियल सिस्टममा इन्टिग्रेट हुन्छ.
Yes, that is our main purpose.
Okay, got it. Thank you.
Thank you.
So thank you. So I think we are running out of time. So I think I should end the session here along with this question answer. So thank you all the presenters. So there were 6 interesting topics that were presented today. So from my side, I close this session here, and I think we shouldn't miss out the tea, coffee waiting outside. So before we leave, so I'll hand over to the organizer.
With this, we have successfully concluded all paper presentations for slot 2. I would like to sincerely thank all the presenting teams for their excellent research work, innovation and dedication. Now, we shall proceed with the certificate distribution ceremony for all the presentators of slot 2. For this, I would like to respectfully invite our session chair, Dr. Aman Shakir, to kindly come forward and join us on the stage for the certification presentation. Now, for the certificate distribution, I'll call the paper ID one by one. So firstly, we have paper ID 1212, KeyShare Distributed Password Management System. May I invite Ravi Vishal, Sachit Neopane, Sushant Khanal, Trishan Shrestha to kindly come forward to the stage to receive your certificates. Let's give them a huge round of applause. We will take the individual photo sessions and then a group photo. So please stay here after you take the certificate. Group photo. Thank you, team. You may kindly take your seats. Next, for paper ID 1226, Multiple Disease Prediction System, MediPredict, may I invite Sumira Khatioda and Ayusha Bhatta to kindly come forward for the certificate distribution.
Group photo.
Thank you. You may now take your seats. Next, we have paper ID 1228, GAN-based comparative study for high-fidelity celebrity image diagnosing. May I invite Buddha Tamang and Gaurav Vasne to the stage for their certificates. Thank you. Kindly take your seats. Next, we have paper ID 1229, Deep Learning Based Music Source Separation from Newari Traditional Instruments. May I invite Ani Shilpakar, Sumina Awal, Puzon Kozu, Sushant Tewana, and Romik Gosai to kindly come forward. Let's give them a huge round of applause. Thank you, team. Next, we have paper ID 1254, Metalora establishing reproducible standards for dynamic rank allocation in parameter efficient fine tuning. May I invite Ashish Pandey and Gaurav Dahal to please come forward for their certificates. Let's give them a huge round of applause. Thank you. And lastly, for the paper ID 1257, Behavioral Anomaly Detection in Blockchain Voting System, may I invite Isha Bhattrai, Jenisha Shrestha, and Gaurav Thusa to kindly come forward for their certificates. Thank you, team. Once again, congratulations to all the presentators of Slot 2 for your remarkable research contributions, and a sincere thank you to our session chair, Dr. Aman Shakya, for graciously presenting the certificates. Now we have reached the conclusion of our technical session Slot 2. As we conclude, we would like to express our heartfelt gratitude to our respected session chair, Dr. Aman Shakya, for expertly managing the session, guiding the discussions, and providing valuable feedback to all our presentations. And to present a small token of appreciation, may I request Engineer Bikas Chawal, Head of Department of Computer Engineering at Khopa Engineering College, to kindly come forward and offer the token of love to our session chair, Dr. Aman Shakya. Let's give a huge round of applause for his invaluable contribution. All the faculties are requested to come on the stage for a group photo with our session chair. Thank you, faculty. Everyone, please be seated. With the technical sessions concluded, we now move to a 15-minute tea break followed by the poster session that is happening just outside Hall 1. 6 teams have presented the research in the form of posters, providing an opportunity for students and researchers to interact directly with the audience, discuss their work in detail, and receive personalized feedback. This is a space for informal discussions, networking, and exchanging ideas that spark future collaborations. We encourage all the participants and faculty to enjoy the tea and visit the poster displays outside, engage with the presentators, and explore the breadth of research showcased here. Please make the most of this opportunity, and we look forward to continuing the closing program here at Hall 1 after the poster session. Thank you, everyone.